Good day, everyone, and welcome to another problem solving session with Special Maths Academy. So we'll be looking at problem 49, second to the last number theory problem in the exam. That's the National Mathematics Olympiad, first round, senior category. So let's look at this problem. So find the value of, and we have a floor function. Kind of looks scary, right? We have floor function and the sum inside the floor function, and then we have the sum with the floor function in it. Okay, so, and we're giving the definition of what a floor function is, which I believe many of us watching this video will be conversant with. So let's go into this problem. So first things first, we can simplify these summations. Since we have that, okay, let's start with the first one, right? So sigma from n equals 1 to 100 n to the power 101 all over 101 is equal to, you can bring out the 101 out of the bracket, okay, from n equals 1 to 100 n to the power 101. Okay, so now from Fermat's little theorem we can simplify this. 101 is a prime, so that's one thing we should take note of. It's a prime. Okay, so from Fermat's little theorem tells us that for a number relatively prime to a prime p, a to the power p minus 1 is congruent to 1 mod p. Now we have that n ranges from 1 to 100. So it means that for each of the n's in this case, n to the power 100 is congruent to 1 mod 101. And so this is equivalent to, it implies that n to the power 101 is congruent to n mod 101. Okay, so it means the summation from n equals 1 to 100 n to the power 101 is equivalent to the summation from n equals 1 to 100 n to the power, okay, no power, yeah. So, and this is equivalent to, we can just find the sum of arithmetic progression. So this is 100, because there are 100 terms, the sum of the first 100 integers. So 100 over 2 into 100 plus 1, which is equivalent to 50 into 101, which is congruent to 0 mod 101. Okay, so this implies that, I'll just put that here, this first floor function was just to scare you guys. And you know, when you get used to contest math, you see that some things examiners do just to play mind games. So this implies that this first floor function is not having any effects. Okay, so this is equal to why? Because we saw that 101 divides this, so it means this whole here is an integer. Okay, so let's move on. So I'll just erase some things here. Okay, so now let's look at this fraction n to the power 101 all over 101. Now from Fermat's little theorem, what do we know? We know that p for any prime and an integer a relatively prime to the prime p divides a to the power p minus p. Okay, so this implies that, okay, let's just split this, this fraction. So this here is this guy right here is equal to n to the power 101 minus n all over 101 plus n all over 101. Okay. For n equals to 1, 2, 3, up to 100, n over 101 is less than 1, and 0 is less than it. Okay? And from Fermat's little theorem, n to the power 101 minus n all over 101 is an integer. So what does this imply? This implies that the floor function of n to the power 101 all over 101 is equal to n to the power 101 minus n over 101. Okay? So we can simplify this second summation. So what do we have? We have the summation from n equals to 1 to 101 of n to the power 101 over 101 is equal to the summation from n equals to 1 to 101 n to the power 101 minus n over 101, which is equal to the summation from n equals 1 to 101. So I'll just split this fraction here, n to the power 101 over 101 minus the summation from n equals to 1 to 101 n to the power 101. So I just split this fraction here. Okay. So that's just the distributive law of division. So now I want to find the difference between this guy here and this guy. So we have this and this common in both of them. So it means we're looking for n to the power 101 over 101 minus n to the power 101 over 101, and this will become plus, okay, because of negative, so we get positive from n equals to 1 to 101 n over 101, and this is equal to from n equals to 1 to 101 n over 101, and this is just 1 over 101 into 1 plus 2 plus up to 100, and this is just equal to 1 over 101 into 100 plus 1 into 100 over 2. Okay, so this guy here will cancel this guy here, so I have 50, and 50 is our answer, so option B. Okay, that'll be all for this video. Don't forget to like, share, comment, and subscribe, and see you guys in the next video. Till then, keep solving maths. Goodbye, guys.